Okay, this is a similar example to what we did last time. We want to make a box with the maximum volume. So we're going to start with our volume formula. Our volume is length times width times height. The height is all of the blue edges. So the height is just going to be x. The width is all of the green edges. So if you take a look right here, we have x plus the width plus x, and it adds up to 22. So we can add the x plus the x, we get 2x, and then subtract 2x from both sides. So our width is going to be 22 minus 2x. Okay, we'll do the same thing for the length. Okay, the red part is the length. And if you look right here, you can see that we have x plus the length plus x, and that's equal to 90. Again, we add the x plus the x, we get 2x, and then subtract 2x from both sides. So our length is going to be 90 minus 2x. Okay, there's our volume formula. I wrote it a little bit bigger so you could see it. And now we're going to do the calculator part. Okay, we're going to start by typing in our function into y1. Again, make sure you put multiplication in between each parentheses. Go to the home screen. We want to find our critical numbers, so we're going to solve where the derivative is 0. Now, we typically get a lot of answers, so we want to make sure we know how big our x is allowed to be. Because our smallest side is 22, we don't want to cut out more than 11 from each side. We also don't want x to be 0, because then we'll have no volume at all. So we want our x to be greater than 0, but less than 11. So when the calculator gives you 32, you can throw away that number. So the number we want is the 5.122. Now usually they ask you to find the volume, so we're going to go ahead and plug that number into our y1 function. So if we choose this critical number for our x, 5.122, our maximum volume will be 4802.446. Okay, again, there's no directions on this, but basically we're trying to find the point on this curve. We're going to call that point xy that is closest to the point 0,2. So we have 2 points. So we're going to start off with a distance formula. The distance between 2 points is, and we'll plug in our 2 points. Again, we don't want the x and the y, so we're going to replace the y with our function. So our y is equal to this. And you don't have to do any simplifying. You can just leave your distance formula like that. Remember, we want the minimum distance, so we're going to want to minimize this. So let's plug it into the calculator and see what we get. Then we'll go to the home screen. Remember, we want to solve where the derivative is 0. Push green, enter. Now it's going to give you a lot of answers. We know that the closest point is going to be somewhere around here. So somewhere between +1 and -1. Because I got 3 answers that all could possibly be the correct answer, I'm going to check all 3 of them. So I'm going to plug all 3 of those in the distance formula and see which one gives me the smallest distance. So it looks like this critical number gave me the smallest distance. So that's the x value that I'm going to choose. Now here's the tricky part. Our answer is going to be this point. We have the x value, but to get the y value, we need to plug it into that function. Yeah, my graphing calculator, I'm going to type that function in y2. Then we'll go to the home screen, and we'll type our critical number into y2. Yeah, I want you to notice I typed the entire critical number in, not just 0.599. And there's our final answer. I want to point out that you can also use 0.600 for the 0.599. Remember, rounding is allowed, but you would want to put both zeros because that means that it's a rounded number. I prefer to truncate, and that's because there's less thinking involved. So there's our final answer there in the box. Okay, we have 2 positive numbers. Those numbers are going to be x and y. We want to find their maximum product, so the product will be when you multiply the 2 numbers together. I do need to replace the y with some function of x. So we can use this sentence right here. It says the sum of the cubes of 2 positive numbers is 99, so equals 99. We can solve this for y, and we'll replace our y with that third root. Okay, there we go. That's our product that we want to maximize. Let's get the graphing calculator and do that. Okay, I'm going to start by typing in the function in y1. Okay, the third root is the same thing as the power of 1/3. Go to the home screen, and we'll solve where the derivative is 0. Okay, our critical number is 3.6717. Remember, it doesn't want the x value, it wants their maximum product. So we can plug that x value into the product function, and we'll get our maximum product. Remember, that product function is in y1, so we're just going to plug our x value into y1 of x. Of course, I'm plugging in the entire decimal, not just 4 decimals of accuracy, but every single digit. Okay, their maximum product is 13.481. Okay, we're trying to figure out what could the maximum area of this rectangle be if the bottom was on the x-axis and the 2 points were on the curve somewhere in quadrant 1 and quadrant 2. So let's first figure out what is the area of this rectangle. Area is going to be length times width. The width is the distance from here to here, so the width is just going to be y. Okay, the length is going to be the distance from here all the way across. Now we do know that from 0 to that spot is just going to be x, and this is an even function, so the distance from 0 to the other side is also x. So the total length is going to be x plus x, so that's 2x. Now our area function has x's and y's, but we can trade this y for the quartic function. Here we go. Now we have our area function as a function of x, and we can just plug it into our graphing calculator and get our critical number. Okay, let's type it in y1. Okay, then we'll go to our home screen, and we'll solve where the derivative is 0. Okay, if you look at our graph, this is a 1, and this is a -1, so we're expecting answers near those numbers. One of our answers is 0.667. The other answer is -0.667, but our x is clearly a positive number. So this is our only critical number that we're going to accept. If they want the area for this particular x value, then you'd plug into the area function. Let's do that right now. Remember, our area function is in y1. So from the home screen, we'll just do y1 of our critical number. Notice I'm using all the decimals of accuracy. And this would be the maximum area. Again, you could change that last decimal to a 6 if you wanted to, but I prefer to truncate it, so I just leave it like this. Okay, they're giving us the cost function. So you plug in any x value, and that'll tell you the cost to make that many. What we want to do is minimize the average cost. So to get the average cost, we need to divide by x. This function is called c bar. And that's it. It's that simple. That's the function we want to minimize. Let's plug it in the calculator. We'll type it in on y1. Okay, then we'll go to the home screen. We want to solve where the derivative is 0. Okay, it's giving us two answers. One of them is positive, one of them is negative. It doesn't make any sense to have negative number of units. So our only critical number is going to be 1.290. Okay, if we want to find out what the average cost is per unit for this many units, we just plug in this critical number into our average cost function. Remember, we stored that in y1. You can see it there in y1. So we're going to go to the home screen. We'll do y1 of that number. And the average cost per unit is going to be 129.205. Now, you could also put 206 if you were to round up. And because it's money on the AP test, they might even accept it with a 0.20 or a 0.21. But if I were you, I wouldn't risk it. We always put 3 decimals of accuracy. And remember, when you buy gas, they do charge you 9/10 of a cent. So go ahead and put that third decimal, even though it's money. Okay, for this example, they want us to find the area of the triangle with the least area in quadrant 1 that goes to the 0.24. So obviously our area is going to be 1/2, and then the base times the height. Okay, we got to figure out what is the base and what is the height. For the base, we're going to take the bottom. That's going to be the base. And for the height, we're going to take the left side. That will be the height. For the equation of this green line, we're going to use y equals mx plus b. We know that whatever the x-intercept is of that line is going to be the length of this base. So let's find the x-intercept by using a 0 for y. Let's solve it for x. And there we go. That's our x-intercept. And that's also the distance from here all the way to here. So that will be the length of our base, negative b over m. Now we also know that the y-intercept of this line is going to be the length of the height. To get the y-intercept, we're going to plug in a 0 for x. And we get y equals b. So b is the y-intercept, and b is also the distance from here to here. So b is the length of our height. Okay, now we do have our area function, but the problem is it has m's and it has b's. So that's too many letters. So we're going to replace either the m or the b, it doesn't matter which one, by plugging this point here into y equals mx plus b. And then we can either solve for m or solve for b. I think the easiest thing is to solve for b. And now we can trade the b for 4 minus 2m. And now we're done. Now we have our area function. We can simplify it a little bit. But notice that our area is a function of m, so it's a function of the slope. So it depends on our slope. I want you to notice that our slope is negative. So when we get our critical numbers, we're only going to accept slopes that are negative, or critical numbers that are negative. Okay, we're going to type it in our calculator. We are going to use an x, not an m. So whenever we see an x, we have to remember that it's an m. Now we'll go to the home screen, and we'll solve where the derivative is 0. Okay, it's giving us two answers. They say x equals, but remember that's m. So our critical numbers are m equals positive 2 and m equals negative 2. Remember, the slope of our line is negative, so we're only going to accept the negative one. Now it does ask us to find the area, so we're going to have to plug our critical number back into the area function. Remember, our area function is in y1. You can see it right there. So from the home screen, we're going to do y1 of negative 2. Okay, the answer is 16. And so the triangle that goes through the point 2, 4 that has the least area would have an area of 16. Any other triangle that goes through that point would have an area larger than 16. Okay, this one is similar to the boat example we had last time. It's just a different story. So this one says you're trying to get away from Jason, who is chasing you with a knife. You can get to the police station if you stay on the road for 22 meters, then turn right at the intersection and travel another 400 meters, or at some point along the road, you can cut across through the cornfield. Now you do run faster on the road. You run 20 meters per second on the road. And in the cornfield, it's only going to be 17 meters per second. But it is a shorter distance through the cornfield. So we're trying to figure out what is that spot where we want to cut through the cornfield and get to the police station the fastest. So we want to minimize the time, but there are two times. There's time that you're on the road. We're calling that TY. And then there's the time that you cut through the cornfield. We're calling that TZ. Now, if you remember, distance equals rate times time. So if we divide by R, we can get that time is D over R. So for each time, we can replace it with D over R. Now the R is just the rate for each thing. So the rate for Y is 20 meters per second. So we're putting a 20 for the rate for Y. The rate for Z is 17, so we're just putting a 17 for that rate. Now you'll notice I'm not writing meters and seconds, and that's because all the units are the same. Everything is meters and everything is seconds. However, if you had it mixed up with minutes and seconds and meters and feet and all these different things, then you'd have to be a lot more careful. Okay, we're almost done. Now we just need the distance for Y and the distance for Z. We can see that Y plus X is equal to 22, 22. So we'll solve this for Y, and there we go. The distance for Y is going to be 22, 22 minus X. Now let's solve the distance for Z, this distance right here. We do have a right triangle, so we can do X squared plus 400 squared is equal to Z squared. We want to solve this for Z by doing the square root on both sides. The square root of Z squared is the absolute value of Z. We can trade that for plus or minus Z. And because Z is a positive distance in this example, we're just going to take the positive answer. So the distance for Z is going to be this square root right here. And now we're done. This is our time function that we want to minimize. Let's plug it in our graphing calculator. We're going to type it into y1. There we go. And now from the home screen, we want to solve where the derivative is 0. Okay, our only critical number is 645.427. We already have the answer right here. Now we do need to double check that that's what the question was asking for. The question wanted to know how far from the intersection should we cut through the cornfield. So the distance that they're asking for is X. And that is what we found. We found X. Now, if you remember earlier, I did not put meters, I did not put seconds, all that kind of stuff. But when you're done with your problem, especially if it's a free response question, you want to make sure that you have the units correct. This is a distance, and the only units that we used in terms of distance in this problem were meters. So we need to say meters on our final answer. There we go. Now we are done.